The Coriolis effect describes how wind is manipulated due to the Earth's rotation. As seen in the drawing, in the northern hemisphere, wind is deflected to the right, and in the southern hemisphere, wind is deflected to the left. This is all in a low pressure system. This results in a counterclockwise rotation in the northern hemisphere and a clockwise rotation in the southern hemisphere. There are three factors combined to direct horizontal airflow. These three factors are pressure gradient force, the Coriolis effect, and friction. When looking at a pressure system, we know that wind will go from high to low pressure, as seen in the drawing. This is the general idea of what pressure gradient is. When considering the Coriolis effect, we know that wind is deflected to the right in the northern hemisphere and to the left in the southern hemisphere in a low pressure system. Friction is considered when talking about surface wind, but not upper level wind. Friction can also alter the direction of the wind. Without friction, as seen in this drawing, the pressure gradient force and the Coriolis effect move air across these isobars until they are parallel. With friction, wind moves across the isobars at an angle. This is because pressure gradient force is not affected by the wind. Wind speed. This causes our surface winds to move slower than upper level wind. When the isobars are closely spaced out, we have stronger winds. When determining the direction from which wind blows, we always say the direction in which the wind came from. Therefore, we would say a north wind came from the north and is going towards the south. As seen in the diagram, in a low pressure system, warm air rises. The wind converges and forces air upwards. Here we will see more precipitation and more cloud formation. In a high precipitation zone, cool air descends, resulting in good weather. The high pressure zones are considered to be anticyclones, whereas the low pressure zones are considered to be cyclones. As previously discussed, low pressure zones result in air rising, and high pressure zones result in air descending. At the doldrums, or the equator, we see a low pressure system due to the convergence of our trade winds, as seen in this diagram. At the horse latitudes, we see high pressure zones, therefore air is descending. The climate is typically warm and dry here. The general circulation of the atmosphere impacts the climate of certain areas. The combination of the Coriolis effect and the convergence results in air rising. At the equatorial low, also known as the intertropical convergence zone, we see diverging air. Here we will see hot and dry weather. As the westerlies move poleward, we see stormy weather in this polar front. The equator and the subpolar zones are at low pressure zones. At low pressure zones, we see an abundance of rain. The high pressure zones are seen at subtropical and these polar highs. We won't see as much rain here.